Ever type a word into a search bar, hit enter, and get exactly 0 results, only to realize the database actually had what you wanted, but it was listed under automobile instead of car? Traditional search engines are literal. They look for the exact string of characters you typed. If the letters don't match, the search fails. The machine has no idea what the word actually means. It is the equivalent of walking into a grocery store to buy cereal, and instead of looking for the right box, you pick up every single item in the aisle and read the label, letter by letter, to see if it matches. But humans don't shop like that. We scan the aisle, bypassing the noise, and spot a bright color from 20 feet away. Semantic search mimics that human intuition. It ignores the exact spelling and retrieves information based on the underlying concept. It knows that automobile, vehicle, and car all have the exact same vibe, which creates a fascinating problem. Computers don't have brains. They don't understand concepts or vibes. They only process numbers. So how exactly do you teach a rigid, calculating machine what a car is? To see how the machine learns, we have to look past the search bar and get down into the system's memory. Feed a word into an AI model, and it translates into an embedding, a dense list of numbers. Each position acts like a slider on a sound mixer, capturing a specific, independent feature of meaning. By assigning these values, the machine generates exact mathematical GPS coordinates for an abstract idea. Through this process, human language becomes a plug-in compatible vector. It gives the computer a universal mathematical way to map out the things we say. On this 3D coordinate plane, every concept has a precise location. The database interprets these points as directional arrows, extending from a central origin. For car and automobile, the machine sees 2 arrows pointing in almost the exact same direction. To measure this relationship, it uses Cosine Similarity, calculating the exact angle between the arrows. Because car and automobile share nearly identical features, the angle between them is incredibly small. The math tells the machine these 2 concepts are practically the same thing. But if someone searches for an apple, that arrow points in an entirely different direction. The wide angle signals the ideas are completely unrelated. The computer isn't reading the letters. It isn't analyzing the grammar. It is simply calculating the geometry between lines to understand human intent. Once you stop relying on letters and start relying on geometry, the system scales up in ways traditional databases cannot. Because the core output is just a list of numbers, you aren't limited to text. An embedding model can take audio, a block of code, or a photograph, and map them all into the exact same vector space. The image encoder analyzes the photograph for visual features, like subjects and actions, translating them into the same numerical slider values used for text. This alignment allows both the text prompt, dog on a skateboard, and the actual photograph of a skateboarding dog to land on the exact same coordinate location. The cosine similarity formula measures the angle between the written prompt and the visual picture and ranks the connection perfectly. For decades, Command F and exact match databases trapped our information behind rigid spelling rules. Semantic search bypasses the syntax entirely, linking ideas across formats. The bridge between human concepts and machine logic is geometry. By reducing the complexity of meaning to the simplicity of angles and coordinates, we've turned the abstract world of ideas into a calculable map.